All right, and we are live. Welcome back, everybody, for the fifth week of Tech Bytes, and specifically the Python session. Looks like we have some people who are staying with us, and some people who are, leaving and coming. But as always, we greatly appreciate you guys coming. And without any further ado, let's get into this week's session. Quick introduction. You guys know me from the past month. My name is Rayan Siddiqui. I'm a rising senior at James B. Conan High School. I love to code. I hope you got to see my passion throughout all these sessions. If you want to find out more about me, my website is right there, rayansiddiqui.com. And my partner, Andrew.
Thank you for the introduction, Ryan. As always, my name is Andrew. I'm going to be a freshman at Purdue University soon. I code a lot, like my partner. I have an interest in graphics programming, and I illustrate as a hobby. I've done a few projects, and you can check them out at my website at andrewchoi.info.
M-Vol-Yi is asking who is older. Andrew is, I think, a year older than me. He is technically.
Yeah, I'm like 18, so.
Yeah, all right. And so you're a year and a half older than me. Wow.
Yeah.
Oh, hi, Arav. Oh, okay, Arav. Okay, we know you from last session. Great to see you back, man. All right. So today's agenda. We want to answer some quick questions about anything you guys may have had while doing the higher or lower game from last week. We know that it was a longer type of session we've had. It was around 50 minutes, I believe. You can, as always, find it in our YouTube channel if you want to go back. But I'm not sure if we're going to have that many questions as we don't have that many people. But after that, we're going to discuss some new terms, such as lists and types. And then we're going to apply those concepts and those terms into some actual block coding to see how they all intertwine and work. So let's get started.
All right. Should I just explain this part or?
Yeah.
All right. So for the higher lower game, hold on. Are we doing edgy blocks? Yeah. Okay. Higher lower game, we had. Should I just go overview it again?
Yeah.
So for the higher lower game, we kind of took all the things we learned over the course of these lessons and really combined it into a single program of sorts, an objective, if you will. We combined the lists for repeatedly running the program. We combined variable assignments for how we formatted our guesses and checked those guesses with if statements and else statements. And as a bit of a bonus, I'm not sure if everybody did this, but we even did a break to show additional functionalities with the loop. So, yeah.
And if you guys have any questions about last week, we'd be open to answering them right now. But if not, we can keep on going. I know, Arav, you were here last week as well. If you have any questions. And Ridema, you were here as well. I'm assuming you guys are good then? All right. Looks like we got a positive response, right? All right. So today, one of the most important things we're doing today is discussing some more terminology. And as Andrew explained, in the past couple of weeks, we learned about variables, functions, while loops, for loops, and print statements, essentially. And we learned how to combine all those ideas into one cohesive project, like the higher lower game. Well, we're going to start up again and learn some new terminology now in order to make some bigger and cooler projects. So the first term, which we want to go over today, is, before actually a deep dive into what the terms are, we want to first start off with types. Andrew, do you want to kick it off?
Sure, why not? We have types in computer science and programming. So what are types? So as you know, we've been working with variables for a while, and you've been noticing that variables can store a plethora of different things. We can store words, we can store numbers to represent, say, how fast the car is going, or maybe just guess a random number to guess in a question. And you'll notice that these are very different types of variables. And the way we actually represent that is that we have these discrete types that we assign to different variables. So for instance, if you're working with very numerical data, you're, for instance, working with the data associated with uh, an age, for instance, like I am like 18 years old. Like I just said, if you want to store that, you would use an integer variable type. If you wanted to store a phrase or like a word, so like if you wanted to store the entirety of William Shakespeare, you put it in a string or a series of strings. For in terms of like how a computer actually knows these types, think of it like how you might not use a word to perform a calculation. I wouldn't, if you are to like tell the computer to compute banana divided by 5, that would not work. The computer would tell me that's the wrong types, fella. You can't use that.
Yep.
So just know that when you are giving types to variables, computers will reject certain actions you can do with them based on what type of type it is, if that makes sense. So let's go on to the next one.
Yeah, and really quickly, Andrew, if you want to show that like in real context, show how like an error statement is printed out. If we
I want to do that when we get to the actual like EduBlocks thing.
Both ways then. Okay, yeah.
Yeah. Well, we have a question. Are we doing EduBlocks? I think we already answered that to Arav, right?
Yeah.
All right.
All right. Now the second term which we want to go over today are lists. Now lists you might have heard them as called arrays or lists, but the main idea is that these are areas which can hold a lot of data in one place. So say you have a list called classmates names. So that list is going to have multiple string values of your friends and your classmates' names in it. And a list allows programmers and people like us who code to hold multiple values which are of the same type. So what do I mean by that? Meaning, you can't have an integer like the number 5 and the word banana in a list because they're two different types. However, you can have the same type in a list. So say I have a string list, then I can store all of the fruits that I want. So like say I have a list called fruits. I can store bananas, apples, mangoes, whatever I want. But if I have an integer list or a number, or any type of numerical list, I can only store numbers like say integers like 5, 6, 7, 8, 9, 10. It wouldn't work, and we would get an error statement saying that we can't combine an integer and a string into one list. And we later today will show how useful lists are in being able to store a lot of data into one area, and we'll show some pretty cool stuff with that as well as we move on to the actual block coding.
All right. So there's another thing we should know about lists, and that's they are ordered, meaning that the order in which you place items into a list matters. If you want to have an analogy, we have this stack of weights. Think of the way you order things in a list like using an index. You might, for instance, if you have a long stack of weights right here for storage purposes, you would call the one at the very bottom the 0th index. And then one after that, the first index. And after that, the second index, going on to the last index at the very top. Now, the way this should work for you is that when you add an item to the list, it will increase the length of this actual list and increase the length of that list. So for instance, if we count the amount of weights here, it's like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. you would actually say that the last item in the list is indexed with 15 or one less than the actual length of the list, whereas the one at the bottom is indexed with a 0. That's kind of hard to get without actually practicing with the code. So we will do that shortly. Just imagine this analogy in your head as we go through it.
Yep. And as Andrew said, what better way to know how to actually apply these concepts than actually coding? So if everybody can please open up the block coding website. I'm pretty sure that we all at this point have it favorited or bookmarked, but I'm going to leave it on here for a couple more seconds if in case you lost it. All right, and then we will open the website. And as always, please be sure to click the Python 3 button. And now we can get started and apply some of those concepts.
All right.
We'll quickly wait a minute real quick if everybody can confirm that they are inside the website in the chat.
It should work on the iPad, correct, Ryan?
Yeah, it should still work on the iPad, yo. If Andrew, you want to type the website in the chat real quick?
Oh, sure. Let me get the link out real quick.
Yep.
Should be in our classroom. All right, here's the link. Make sure to select Python 3. That is the language we are doing. Hold on, I accidentally sent it to only panelists. Now everybody should be able to access it if you don't know how to get in. All right, so good to see you are in, Mantra. Let us get into that coding.
Yep. All right. So we can get started now. All right. So Andrew, I'll just do the basic show like a list, and then I'll let you get the access, and then you can start looping and show the indexing.
Sure. Can we do the whole type exam with the banana real quick?
Yep. So I'm gonna hand on over to Andrew really quickly to show example.
Right. So, well, first, if we're not all used to the actual program, just know that, hey, Ryan, could you resize it so I can show how the run button disappears? Okay. So just as a quick reminder, if you have this 3 bars at the top, the run button will be right here, as opposed to, could you resize it? As opposed to when it is enlarged, if you're something on a desktop, the run button will be over here. That will be useful for when we want to execute our code later. But for now, let's actually demonstrate what a type is. So let's say you had a variable. Well, we'll call this string variable. That's the variable type associated with words. Let us get that in. So do know that when you want to declare or say that this variable is a certain string type, you would use quotation marks. So I have 2 quotation marks right here, and I put a word in. Let's just do what we've been doing before, banana. Now, keep in mind that the type is tracked throughout the program, so the computer will know what type of variable is. So let's actually perform some logic with it. So first, let's get a print statement so that we can actually see what we're printing out. Then we want to go into math to do the actual calculations that we set in our banana example. Place it in right here. There we go. And string variable. And just to clarify, everybody is caught up with this part of the program. I'm not sure if anyone is new to this. Hold on, someone says something in Q&A. All right, Redeemer says it's okay, and I'm guessing Mantra's probably having a good idea of it too. So let's actually do that calculation. We're going to divide banana by 5 and see what happens. And we see that, yes, you can't do that. You can't divide banana by 5. That is, computers will not allow you to do that if you can't divide a string by 5. You'll see that right here. It's str, short for string, and int for numerical value. That is the 5. And you'll see that if we instead had something like, I don't know, 12, and we run it right now, you'll see that it does work. 12 divided by 5 is very much 2.4. That's how types are important to how computers interpret your code. So, Rayan, can you take over with what you wanted to say for the next part of the lesson?
All right, thank you, Andrew. So hopefully you guys understand that types are super important in terms of communicating with the computer efficiently and making sure that you aren't dividing a string like banana by a number like 5. All right, so now let's apply the second term we learned today, that being lists, and deep dive into more of the details surrounding what indexing is and all that good stuff. So how about we first head on over to the left, select a list, and how about we go with let's go with the string list. I think that'd be pretty cool. So how about we drag our list down here. We'll click on the drop down really quickly and make a new variable and call it, let's say, a fruit list. Just to make it easier. Now, right now, this is supposed to be a fruit list. However, can anybody tell me what type are in the fruit list right now? And what should we change it to as a bonus? In the chat, please. Yeah, the question is, what type do we have right now in the list? And what type should we change it to so that it can hold fruits?
Mantra, you're saying you're stuck. Could you be a little more specific with your problem?
Okay, Matra, let us know if you have a problem though, but it looks like Arav has the right idea. He said that right now we have the type of numbers or integers. Okay,
it's for the question. Yeah, right.
Okay. Yeah, so we'll explain it right now. So basically, like Arav hit the nail on the head, right now we have numbers or the type int in our list. However, to hold the names of fruits, we're going to need what Andrew was explaining, quotation marks firstly, in order to hold the name of a fruit. So let's say what fruits we want. We'll say apple, we'll say banana, and we'll do a mango, and how about a strawberry? Now notice how each fruit needed its own quotation marks. Otherwise, we're going to get an error. And now, I'm sorry if I pronounced your name incorrectly, Mantra. Now we have a list with string values instead of numerical values. And it actually has fruits names. And if we want, we can really quickly print out our variable holding the list. Head over to statements, print, drag the fruit list like such, and then we can run it and see that our list is printed out in a string type format with all the fruits names. Now, that's pretty cool. And we can see now how types and list actually intertwine, connect pretty nicely. Because say for instance, let me show you another case. Say I add the number 5 to this list. Now remember what I said at the earlier of this session, that combining types into one list is a bad idea. Can anybody guess what's going to happen? Well, oh, I'm not printing. Yep. R is correct. This will crash and there will be an error.
But it's like lazily evaluated in Python, right? So it shouldn't.
Yeah.
Like, yeah, let's just do a quick print and it should like show the error.
Yep.
It's very Haskell-like. All right, so we will now print it and we will see the error. Okay, wait, this is a Python list, so it's actually a little different.
Yes. Okay, so I won't explain this right now, but in Python, you are fine doing this, but say in a different programming language like Java, this would not fly.
Yeah, so just like, this is just something special with what we're doing right now.
Yeah, but in general, we would recommend that you guys try to keep your list one type. It's a general idea which would help you in the future.
And we will actually exemplify it right now. Say you had a list of both strings and numbers, and you try to, say, iterate through it. We should actually show the iterating it through right now.
I'll go through that right now. So, all right. So Andrew earlier explained indexing with the analogy like we like to provide of weight stacks. Now let's see, before actually I loop through it, I want to show the indexing and printing out. Let's see, where is here we go. All right. So say I head on over to my fruit list and I want to print one fruit only. I want to print the mango. Now, this number represents which index or which place in the list I want to print. So right now, it's saying the third position. Well, the third position right now is not mango, it's strawberry. Because remember, like we explained earlier, lists start at the 0th index. So apple represents 0, banana represents 1, mango represents 2, and strawberry represents the number 3. So the index 3. So if I want to print mango, I'm going to have to print the second index. And I'll run that really quickly. And we see that the fruit mango is printed. Say I had the third index, mango would not have been printed, but instead strawberry, because indexing is a bit different and indexes start as 0 in a list. Now, Andrew, do you want to show it in a loop format?
Sure.
Okay, so now Andrew will show you how we can iterate. And if you don't know what that means, essentially it means to go through each element, each type in the array, and do some neat stuff with that.
All right, so we should probably like give us a quick refresher on what a loop is. It executes code repeatedly. But this time, we are not actually using the while statement. We are using a different kind of loop called the for loop. And this, sorry, wrong one. We will be using the for x and y. Now, what a for loop does is that generally it goes through a series of items. So in this case, what we will be doing is we will be going through a series of items in the fruit list. So let's actually do that right now. We will take the for x and y. The way the sort of like a syntax works here is that you put the x in the fruit list and we just say something like an actual item, name the item. We'll call it like fruit. So for every fruit in fruit list, we will do something with that variable. So let's actually do something with it. Let's do something simple as printing. So let's actually put it right here. And we will print out the fruit variable. That is, of course, an item in the fruit list. So let's put this in here. It should run correctly. And there we go. Apple banana, mango, strawberry. And notice how, as we have said, it prints it in order. The for loop goes in order in the list. Now, just to go back to what we were saying about making sure you have only one type in your list, this is one of the main reasons why you do it. If you're, for instance, wanting to print out each variable, let's say you didn't even have like strings. Maybe you have like, let's actually rename, say, another list. I'm just going to rename it for now for like brevity. Let's say you had a series of.
Oh. One sec.
Just slight technical error.
Okay, the window shut. Give me 1 sec. Okay, here you go, Andrew.
All right, thank you. So just for example, let's actually change tracks for a second and actually say that you had a list of, not ages. Let's say you have a bank account, right? And you have a series of bank accounts and you want to print out the amount of money in a bank account. And you might store that in the form of the amount of cents each account has. Like this, you had like $5 in account, you have roughly 500 cents. In this case, let's say someone has, of course, they'd be really poor if they had this, but 300 cents in one bank account, 900 in another, 990, let's say 450. And just to give us an example of what we can do with these types of iterations, we can do calculations based on those variables. Sorry, based on those values in the variable list. So let's actually do that. Let's go to print. Let's go to math because we're doing calculations. And we are going to say that for a fruit, sorry, not a fruit, we should probably name this to something more meaningful, like a cent. Let's just like say cent amount. Just for now. You can name it as well, anything really, as long as these two variables have the same name. And let's divide it by 100. And that way, if you know your basic currency exchanges in USD, 300 cents should go to $3. 990 cents should go to $9.90. So we will see this in action. And you will see that bank account has $3. Bank account number 2 has $9.9, and bank account number 3 has $4.5. Now, this, we should also say, this is why you should only have one type in your list. Say, for instance, you had another one that just randomly had George, just George in your list. What would happen? Let's actually see. There's an error because you can't divide a string by int. So that's why we just want to tell you that it is best practice to make sure your lists only have one type in it. Because if you perform calculations with it, you might accidentally do something like, say, dividing a string by an int. So there we go. Should I just move on to indexing as well?
Yes, I could. If you want, I could do it.
Yeah, you should probably do. My voice is getting a little hoarse.
So thanks, Andrew. Now, remember earlier we talked about how indexing works in a string. We showed how if I print the 0th or first index, we get a certain type of fruit. Well, it works similarly in an integer type list as well. So let's go a bit basic and say we want to print let's say we want to print the last cent in the bank account. So we'll drag our list, look at the second index because 0, 1, 2, we run, and then we see that we get printed for cents. 450 cents. Now, that's because, remember, the 300 cents represents the 0th index, the 990 represents the first, and the 450 represents the second index. So say if we... I think that should be fine, but...
You mean like, are you gonna do like the range one or?
The range one?
Yeah, the for loop with the range index.
Okay, yeah, sure.
To show that this is a different way of like looping through it.
Yeah, all right. And another way which we can loop and get values inside of lists is by using a for loop, but not like the one which Andrew showed of saying like a cents in cents array. We can actually loop it the number of times the length of our list. So if we head on over to list, is there a list length command here?
We can always just set to 0 to 3 range.
Okay, yeah. I don't think this website has a length command, but there's also a way for us to get the length of the string of the list and then run the for loop that many times. But since we know this time that there are 3 values, we'll put a 3. And now let's say we want to print each value. So let's go to print list. And now I'm not going to specify a specific value. Like I'm not going to put 0, 1, 2, or 3, or 4, whatever. I'm not going to put a specific index. Well, instead, I'm going to put the variable I. You might ask why? Well, it's because I represents the position at which the loop is at, and this way we can get whatever value is at the specified positions. So say like we do that same example which Andrew showed, and we do the math operation of dividing by 100 in order to get the amount in dollar format in USD. And this will show you that oh, I forgot we renamed the list. Here we go. And this shows you another way of how we can loop over our list of cents in bank accounts and get a numerical value, do some operations, and shows you how indexing is very useful in order to get specific data from these lists.
Should we like show how to append also?
Sure, yeah. So we'll show you something cool today, and you guys don't have to get the whole, get a whole idea, but we've showed you indexing in list and how you can get specific positions. Well, there's other stuff which you can do as well. You can remove items from list, and you can also add items to list. So say we head on over to our list command. We head on over to list.append. I'm actually going to show this without a for loop first. And we specify our list as a cents list. And we can now add another value. So say we add a bank account with 760 cents. Well, let's print the list at 2 different stages. The first, let's print this, our list without it being manipulated. And then we'll print it after we add a value.
Since
oh, yep. That should be good. Notice how first, when the list was not manipulated, it printed out the values which we specified when the program ran. But then after we added that .append command, which allows us to insert more values, the next time we printed the list, we saw that the 760 cents was added as well.
And this is similar to the example we showed earlier with the stack of weights.
Yep. So
can you guys slow down and show the code? All right. Is there any specific part that you want to show again, Sharia, or?
And as always, guys, you can find examples of what Andrew and I are covering on the Google Classroom in our weekly updates and in our Python and JavaScript folders as well.
Sorry for going a little fast. We will be able. If you have any problems, you need us to slow us down. Just a little. Always contact us.
Yep.
Right now in the chat. And if there's anything you want to go over again, do tell us. We are here to help you learn.
And I think that's where we will end it off for today. And we've covered a lot of material today. Just to recap, we covered types and a whole bunch of things with lists, such as indexes and going through looping over those lists, those data in the lists and performing some calculations. And yeah, so for next week, we will post on Google Classroom a place for you guys to submit. We want you guys to make your own type of list, whether it be a video games list or it could be a food list like we did. And we want you guys to mess around and print out the different indexes and make sure that you know why the first position is actually the 0th position and not the first position. And as always, if you guys have any questions, Andrew and I are always checking the Google Classroom where we will answer any questions. And you can find the code examples there as well. And I believe that is it for this week. As always, take care. See you guys. Bye.